Flip geometry. Once again, we're going to go ahead and get into 1-7, which is three-dimensional figures. After this lesson, you'll be able to identify and name three-dimensional figures, and you will be able to find the surface area and the volume of these figures. The main thing we want to talk about today is a polyhedron, which is a solid with all flat surfaces that enclose a single region of space. The three main parts of a polyhedron are a face, an edge, and a vertex, and we're going to talk about all three of those here shortly. Each flat surface or face of a polyhedron is a polygon. In this figure here, if you were to count them, you would see that there are 6 faces. It's kind of hard to explain just by looking at a picture of this polyhedron because these are 3D figures. But if you were to hold your phone in front of you, most of you have a box-like phone, you would be able to see that it has 6 faces. For instance, if you had an iPhone, the front part where you can dial the numbers is one face. The opposite side where the camera is would be the second face, and then the 4 faces around it would be a lot smaller, but that would have 6 faces. The line segments where the faces intersect are called edges. So where two of those polygons meet, that would be an edge. Now the point where 3 or more edges intersect is called a vertex. So that point is called a vertex where the 3 different polygons, 3 different faces of your polyhedron would meet. There are 5 different types of solids that we're going to talk about. The first one being a prism. A prism is a polyhedron with 2 parallel congruent faces called bases connected by parallelogram faces. Now, if you look at this example here, the top and the bottom, those 2 faces are parallel to each other. They're never going to meet. They're on 2 different planes, but they are parallel to each other. Now, again, if you were to use your phone in front of you, the side, the face with the where you can type the numbers, and then the other side with the camera, that would be your base of that prism. And this is a polyhedron. The next one is a pyramid. Now, that's a polyhedron that has a polygonal base and 3 or more triangular faces that meet at a common vertex. So if you look down here at the bottom, it's got a base that is a polygon. It's going to be, it could be, in this example, it's more of a quadrilateral, but it can be a bunch of different polygons, and you'll see them in here in a moment. But the sides are going to be triangular faces that they all meet up at one point up here at the top, which is called the vertex of the pyramid. Now, a cylinder is not a polyhedron. It's actually a solid with congruent parallel circular bases connected by a curved surface. So again, we've got 2 bases here that are circles. I'm just going to highlight those, and they are again parallel. And then they have one, and those are the 2 bases. The circles are going to be the bases of your cylinder. Now, and it's wrapped around by a curved surface. One example that I can give you is probably like a roll of toilet paper. The top and the bottom are going to be your circular bases, and then the actual paper wrapped around it, that's just going to be a curved surface. A cone is a solid with a circular base connected by a curved surface to a single vertex. So it's going to be one circular base here at the bottom, okay, and then a curved surface which meets up here at a point which is called the vertex of the cone. And then lastly, a sphere is a set of points in space that are the same distance from a given point. A sphere has no faces, edges, or vertices. So the quickest way and the easiest way I can probably explain a sphere to you is that you have a point here, and then any point on the outside of this sphere is going to be a certain distance. And all of the points, I'm just going to keep drawing, all of the points in, the same distance away from that one main point, they're all going to create what's called a sphere. It's just a set of points that's the same distance from one point. If you can imagine holding a ball and there's a point right in the middle of that ball, any type of ball, a tennis ball or a basketball, soccer ball, if you were to hold it and imagine a point right in the center of it, any distance from the surface of that ball, I'm sorry, any point from the surface of that ball is going to be the same distance from your point right in the middle of that ball. And that's why we call those a sphere. We can further identify polyhedrons by the shape of their bases. If we look at these three prisms up here, this first one would be a triangular prism because its bases are going to be triangles. Then we have a rectangular prism and then a pentagonal prism. Again, we look at the shape of their bases, whatever that polygon is, that's what we're going to call that prism. The same thing with the pyramids down here. The base of this triangular pyramid is a triangle. This one's a rectangle. Down here we have a pentagonal pyramid. Let's determine whether the solid is a polyhedron. Then we need to identify the solid. If it is a polyhedron, let's name the bases, faces, edges, and vertices. So we're going to start with naming it, and it is a polyhedron, and specifically it's going to be a rectangular prism. Okay, we can see that the bases are both going to be rectangles, and I'm just going to highlight the bottom base here so you can see it. That's our rectangular base. Okay, and I'll just go ahead and highlight the top one too so you can see the two bases. Both of those are rectangles. It is a prism, so we're going to identify it as a rectangular prism. Let's start by naming the bases. Because they are rectangles, they're going to have four vertices, and we can begin. And I'm going to use a different color here by calling this first base E, G, H, F. That's going to be our first rectangular base. We're going to start just with the bases E, G, F, and H, and then the bottom one you can see is just going to be A, C, D, B. A, C, D, B. Now we're going to look at the faces of the rectangular prism, and because it is a prism, rectangular prism, it's going to have six different faces, and I'm going to highlight a few of them and name them as we go along. So of course, the two bases that we just named a second ago, the one I just highlighted, of course, is going to be E, F, H, G. And then this bottom base here that I've highlighted, we're going to name, let's just start with B or A. This doesn't matter. A, B, D, C. Let's continue with the front face. I'm going to highlight this guy up here, and then the back face. I'm going to highlight that guy there too. And let's name them. The front one, we'll start with G, H, D, C. The back one, E, F, B, A. And all these are going to be rectangles. The last two faces we're going to have are the ones here on the side. Go ahead and quickly highlight these guys as well. And now we can name them. Start with the one on here on the left. We could say G, E, A, C, and then H, F, B, D. Those are going to be our six faces for this rectangular prism. Now we need to talk about the edges. Again, the edges are two of our faces of our polygons are going to meet. So I'm going to highlight a few and then we're just going to name them here. Let's start with these vertical ones here. Okay, there's going to be four of them right there, and since they are line segments, we're going to name them. Line segment EA, line segment FB, GC, C, and HD. We're going to continue now with a few more of them. Let's go this way now with it. Okay, let's name these guys. Those are all going to be edges. EF, line segment AB, line segment GH, and line segment CD. The last four that we have are going to be these four. Okay, again, let's name these guys. We'll start with that one, line segment GE, line segment HF, CA, and finally DB. We have 12 edges for this rectangular prism. Lastly, we have our vertices, and those are just going to be the points on this rectangular prism. So I could just name those A, B, C, D, E, F, G, and H. We've got 8 points, 8 vertices for this rectangular prism. Now again, we need to talk about this solid, which is actually not a polyhedron. It is definitely going to be a cone. And we can name this base because it is a circle, it's going to be called circle T, which is going to be our base. It doesn't have any faces or edges, and the only vertex that this guy has is going to be the one there at the very top, of the cone, which is vertex W. Let's go ahead and identify these solids here. If we look at the top one, we can tell it's going to be a prism of some sort, but we need to find out what the bases are. And if we notice, the parallel bases are going to be these two triangles. So we're going to label this guy as a triangular prism. Okay, the one down here at the bottom is fairly simple. It's a cylinder. It's just the circle bases, the curved surface. Now the hard one is going to be probably this guy over here to the left. Now what you're going to need to notice is that it's going to have a vertex, okay, up at the very top. You notice there's a bunch of triangles. It's going to have a vertex up at the top here at X. The base is this guy down here at the bottom, which is just another triangle. So this is going to be a pyramid, but it's going to be a triangular pyramid. And that's one of the hardest ones probably for people to recognize, just because all the faces and the base itself are going to be triangles. But if you notice, that is a triangular pyramid with this triangle JKL as the actual base, and then the vertex is going to be this guy up here at X. Now, a polyhedron is a regular polyhedron if all of its faces are regular congruent polygons and all the edges are congruent. There's 5 of them listed here. There are actually only 5 of them. They have a specific name. They're called platonic solids, named after Plato. Okay, and the only 2 that you're probably going to be familiar with are going to be the tetrahedron and the hexahedron. You know the hexahedron better as a cube, and then a tetrahedron is just like the one figure we just looked at with 4 triangle bases, but they're all going to be equilateral faces. Now that we've got all the vocabulary out of the way, let's talk about measuring some things. The 2 things that we're going to be measuring when it comes to polyhedron or any of these 3-dimensional figures, these solids, are going to be the surface area and the volume of the solids. The surface area is basically a 2-dimensional measurement of the surface of a solid figure. The surface area of a polyhedron is basically the sum of the areas of each face. So if I can just quickly draw, let's see how good I can draw a cube here, or any type of prism. If we looked at this and this was a prism, I would take the area of each of these faces and then add them all up, and I could get the surface area. Now, when we talk about volume, that's the measure of the amount of space enclosed by a solid figure. And without getting into all the numbers and the formulas, the only way I can explain this to you is if you imagine there's a table, and that's what that is, if you couldn't already tell. And I drew a box on top of this table. Okay, let's make this box a blue box. Okay, that turned out better than my table did. And if we were going to um, just shade this in. Let's shade this box in here so you can see that it's a box. I know you needed that just to visualize it. But if you had a box on top of a table, and just imagine the amount of space that that takes up. Okay, um, that is what the volume of this thing is going to be, and we're going to take measurements for this. We have different formulas that we'll take a look at. So here we have the five solids that we looked at earlier: prism, pyramid, cylinder, cone, and sphere. If you take a look at this top row here, those are going to be all of the surface area formulas. And then the next row are going to be the volume formulas that we have for each one of our solids. Let's start by finding the surface area and the volume of this solid. Well, first of all, the solid here that we have here is a cone. So we're going to start with the surface area formula. And if we look back at that chart a second ago, it'd be T equals pi r L plus pi r squared. Okay, each of these letters represent something in this figure, and we're just going to go ahead and plug those numbers in. Pi, r is going to be our radius, which is 3. L is going to be our slant height, which in this figure is going to be 5, plus pi radius squared, again 3 squared. If we continue on with the math, it's going to be 15 pi, 5 times 3 is 15, plus 9 pi, 3 squared is 9. Add those two together, and that's 24 pi, which is approximately going to be 75.4 centimeters squared. And again, you must remember that it is squared because we are taking the area, the surface area of that figure. Now, if we take a look at the volume of this cone, we write down a formula again. V equals 1/3 pi r squared h. Again, each of these variables represent something in that figure, and we're going to plug those in. V equals 1/3 pi. R again is going to be 3 squared, and the height is going to be 4. So if we continue to simplify this, it'd equal 1/3 pi times 9 times 4. Okay, if we simplify 1/3 times 9, which is 3, and 3 times 4, we're going to end up with 12 pi, which would be approximately 37.7 centimeters cubed. And because we are taking the volume of that solid, it'll be cubed. Now let's find the surface area and volume of this solid, and because it is a triangular prism, we're going to start with the formula for a prism, which is the surface area. T equals pH plus 2b. Okay, now what this means is we need to find the perimeter of our base. That's what the big P stands for, the perimeter of the base, and the big B is going to be the area of our base. So we've got to find two different things first. Now, if you notice, our base here is a triangle. Okay, we can find the perimeter, but we need one final measurement here. We've got the 6 and the 8, but we need to know how long that side is there. And of course, we're going to use that find that by using the Pythagorean theorem. A squared plus b squared equals c squared. 6 squared plus 8 squared equals c squared. That's 36. 64. That's going to be 100. Take the square root of both of those sides, and our c is going to equal 10. So now, if we add up 8, 6, and 10, our perimeter is going to be 24. Let's try that again. 24. Okay, we've got our height of the solid, which is 12, plus 2 times the area of the base. And again, it's a triangle, so A equals 1/2 B times H of the triangle. Now, not the figure, just this base, the triangle. We've got our base is going to be 8. Our height is going to be 6. 1/2 of 6 times 8, which is what, 48. Our area is going to be 24. So 24 is what goes in that part there for our big B. Now all we're going to do is get rid of all the rest of this and continue on finding our surface area. We don't need any of this anymore. We've got all the numbers that we need. Okay, now 24 times 12 is going to be 288, plus 2 times 24, which is 48, and our surface area is going to be 336 feet squared. Again, area is squared. Okay, volume, as you'll see, it's going to be a little simpler just because we have some of the numbers that we need already. Our volume is going to be base times height, the area of the base times the height, okay, because it is just a prism. So what's our area of the base? We just found that up here. That's 24. Our height is going to be the height of the solid, okay, which is going to be 12. 24 times 12 is going to be 288 feet cubed. Again, you have to remember that surface area is going to be squared and the volume is going to be cubed. Now this last problem is a word problem, and the one thing that you're going to notice is that you don't have a figure, so we're going to end up drawing one just so we can label it properly. Now Jenny has some boxes for shipping merchandise. Each box is in the shape of a rectangular prism with a length of 18 inches, a width of 14 inches, and a height of 10 inches. Find the surface area of the box. Now, what we want to do here is let's go ahead and draw our box. It doesn't have to be that big. I'm going to draw a rectangular prism. Okay, very simple to draw here. And let's go ahead and label it. Length of 18. We've got 18 here. The width is going to be 14. The height is 10. And if we know it, we'll go back and find our formula for the surface area of a prism. It's going to be surface area. Doesn't matter which one we use. If we go back and look at the surface area, I'm just going to use SA equals pH plus 2B. Surface area equals pH plus 2B. It looked like a 13. Let's clean this up here. 2B. Our perimeter. Now, first we got to figure out which one our base is. Okay. Now, you can use in a rectangular prism is kind of different than any other one of these shapes, is that there are different things or different sizes that you can use a base. But once you use a particular base, you have to use an appropriate height for it. So I'm going to shade in what I'm going to use my base. Usually the base you would think is at the bottom, but I'm going to use this one right here just because we can see it. Okay, I'm going to use that one as the base. So the perimeter of that base is just 10 plus 14 plus another 10 over here and 14 up at the top. That's going to be 48. Okay, our perimeter is 48. Our height of this solid is going to be, since now this is going to be our base, our height is going to be this guy right here, and the height of the solid is going to be 18 plus 2 times the area of our base. Remember, it's just a rectangle, okay, base times height of this. So 14 times 10 is going to be 140. There's our surface area. And from here, we've got all our numbers. We can just do some math here. 48 times 18 is going to be 864, plus 2 times 140, which is going to be 280. Add those two numbers together, and you've got 11, not 64, but 1144 inches squared. Okay, 1,144 inches squared is going to be the surface area of our box. And there you have it. Lesson 1-7, three-dimensional figures. A lot of vocabulary. We found the surface area of some things. We found the volume of some things. Now go ahead and try some of those problems. Look at the other video, and hopefully we'll be ready before the next class. But again, if you have any questions, please let me know.